Hello students, today we discuss the integration by partial fraction. In the last class, we discussed some integrations of different forms like px plus q divided by ax square plus bx plus c. Integration of this form, what we did there, we assume that this px plus q is equals to some a derivative of this ax square plus bx plus c plus b. We made some adjustment by taking the derivatives from here and then we did the integration. Now question is here whether it is factorable. If it is not factorable, then okay, then we can perform the integration by taking this method, that is px plus q equals to this one. If this quadratic expression is a factorable, that means you can make the factors of this quadratic expression, then our integration can be made much easier. So there are some forms which are described in this portion. Let us discuss one by one. If your integration is in the form of px plus q divided by x minus a into x minus b, that means it is in the form of linear by quadratic. Once again the same thing only, but the quadratic form or quadratic expression is factorable. I made two factor here, x minus a into x minus b. That time this type of integration we can split or we can make some adjustment like this, a upon x minus a plus b by x minus b. I made the adjustment or I make two terms from here when this is factorable. If it is not factorable, then we have to proceed the previous method, and if it is factorable, we can go through this a upon x minus a plus b by x minus a. Here this factor, that is x minus a and x minus b, this a and b must be different. Two different distinct factors are there, and here a might not equal to b. But what about if this is a repeating one? That means our integration of the form px plus q upon x minus a the whole square, that means both the two factors, they are repeating, x minus a into x minus a. What happened in this case? In this case what we can do? We can take a upon x minus a plus b upon x minus a the whole square. Likewise, we can split this integrand in these two terms. Similarly, if these two are distinct, x minus a, x minus b, then this integrand can be splitted as a by x minus a plus b by x minus b. Now see, this is the quadratic portion, and quadratic portion, if it is not factorable, then you have to follow the previous rule. That previous rule is what? That is px plus q is equals to a times of derivative of ax square plus bx plus c and some b. This is when this is not factorable one, and if it is factorable, then there is two chances. One is the without repeating the factors, that means distinct factors, and when there will be distinct factor, you must take a upon x minus a plus b by x minus a in this form. If it is repeating factor, then you must take a upon x minus a plus b by x minus a the whole square. That means we have taken all the possibilities of a quadratic expression. So likewise, we can follow the same thing over the cubic form. In the cubic form, you will have, that is px square plus qx plus r upon x minus a, x minus b and x minus c. It is a cubic expression, and cubic expression that all splitted in factors. All splitted in factors, and that factors all are distinct. Such type of problem when arise, you can take these forms, that is a by x minus a plus b by x minus b and c by x minus c. In this way, now the question arises, sir, it may not splittable or it may not factorable. Then of course, maybe we have chances p x square plus qx plus r, maybe there are two distinct factors x minus b, two distinct factor, there may be two distinct factor and one are repeating on, that means x minus a the whole square and x minus b. Three factors are there, x minus a into x minus b. That means two factors are repeating, a is repeating here and x minus b that is distinct. But that means you have two different factors, two same factors and one different factor. In such cases, how can we split these terms? Simply you can assume these terms as a by x minus a plus b by x minus a the whole square and c by x minus b. You can split your integrand in this form. Here a is repeating twice and b is distinct. A and b should not be equal. Okay. Now one more possibilities. Let's see other possibilities. Sometimes what happen, you must have the three repeating factors, that is x minus a, x minus a, x minus a. What we can do for that time? Simply you take integration p x square plus qx plus r upon x minus a whole cube, and that time you must split the terms in such a way, that is a by x minus a plus b by x minus a the whole square plus c by x minus a cube. Likewise, you can split these terms. Okay. Now, there may be some more problems. That problems there, it can be, first we can find one single factor and there may not two more factors. That means after taking the first factor, your cubic equation become a quadratic one, and that quadratic one is not splittable, not factorable. Like situation is something like integration over, that is dx upon x minus a, and that is a x square plus bx plus c. In such form it may arise. That means this part is okay, I have taken one factor, but in the remaining part it is not factorable. So that time our technique of taking these forms or these parts is something different. You have to take here a by x minus a plus bx plus c by, that is a x square plus bx plus c. In this form we can split these integrands. So likewise, quadratic forms and cubic forms you can split in these distinct forms. Here in the first case, px plus q upon x minus a, x minus b, two distinct factors, and the two distinct factors can be split as, that is a upon x minus a plus b by x minus b. A, b should not be equal. When a and b, that means repeating factors will be there, your splitation will be a upon x minus a plus b by x minus a the whole square. When you have the three factors, that means a cubic expression, in that case you have to write a by x minus a plus b by x minus b plus c by x minus c. Third case, we have two repeating factor, but one factor is distinct, and that time a upon x minus a plus b by x minus a the whole square plus c by x minus b. Likewise, 3 repeating factors, that means a by x minus a, b by x minus a and c by x minus a whole cube. This way we can split these integrands, this part only, I am talking about the integrands only. So dear students, likewise you can solve the rational functions which are given in linear by quadratic or quadratic by cubic or linear by cubic. All such problems can be solved by using these forms, and these are the called partial fraction methods. That means we have some distinct methods by which we can split in terms, and that terms our integration become more easy over these parts or over these terms. Okay, now we can solve some problems over these forms, and we can find the solution of integration very easily. Okay, dear students, now I will take some problems, I will take some examples and I show how can you solve. Before that, before solving some problems, we may have arise some one more possibilities. Sometimes what happen, look here, sometimes x square plus 2x plus 3 by x square plus 1. Suppose one integration arise like this. Now look here, you have x square plus 2x plus 3. That means in the numerator you have quadratic form, as well in the denominator you have the quadratic form. That means degree in the numerator is 2, as well the degree in the denominator is 2. That means it is a improper fraction. An improper fraction, we cannot find the solution of improper fraction. First of all, you have to make this improper fraction as a proper fraction. And how can be possible? This is simply by long division method. Here x square plus 1, I use this x square plus 1 and I divide this x square plus 2x plus 3. Here I take 1 and this x square plus 1, this 1 plus 1. So after subtracting, this one I subtract, this part will cancel, you will have 2x and you will have plus 2. Now look here, it become linear. This is quadratic and this is linear one. Now our division is over. I have to make this part, this arrangement by this quotient and remainder. How? Let's see this part, this portion, this is x square plus 2x plus 3 by x square plus 1 can be written as 1 plus 2x plus 2 upon this is x square plus 1. Now see, there are two terms. This is 1 and 2x plus 2 divided by x square plus 1. And this term is easily integrable, and this part is again similar to our either of this form. That means this is px plus q upon this form, or in the previous form what we have discussed in the earlier class, that is 2x plus 2 divided by x square plus 1, that is linear by quadratic form, and in that way you can find the solution by using the previous rule or previous method. So first of all, you must be careful. Dear student, you must be careful while performing integration over these rational expressions. You must check first of all, before entering, you must check whether it is in proper fraction or it is in improper fraction. If it is proper, then okay, we have to see it is coming under which form. It will be definitely in some form. If it is in not in any form, then we have to make it. Maybe there may be some substitutions or maybe some calculations. By doing that, you can bring the integrand in one such forms. But if it is improper, then definitely you have to make it proper. First of all, you have to make it proper, and for making proper, you have to divide by long division method. After long division method, you write the integrand in this form, that is, here you must write your quotient plus remainder divided by divisor. Then you will have the form of one of these. This way you can find the solutions of the integrations. Now let us see this problem. This is integration of 2x plus 1 upon x plus 1 into x minus 2 dx. Okay. Now first of all, whether it is given in proper or improper? It is given in proper form, because you have linear in the numerator and x plus 1 into x minus 2, that means it is quadratic in the denominator. So linear by quadratic, that means it is proper and no need to make it anything. Simply we check whether it is coming under in which form. Now check the first form. Our first form was px plus q upon x minus a into x minus b. If it is in this form, then we can split the terms as a by x minus a plus b by x minus b. So it is exactly the same form of this one. That means we assume that let 2x plus 1 by x plus 1 into x minus 2 as a by some x plus 1 plus b by some x minus 2. Now I make some calculation here, that is 2x plus 1 by x plus 1 into x minus 2 is equals to a into x minus 2 plus b x plus 1 by x plus 1 to x minus 2. Now see, our denominator part, this part or this part is same, so this can be cancelled out. So you will have 2x plus 1 is equals to a into x minus 2 plus b into x plus 1. Here, now as the earlier case, we can compare the coefficients of x and the constant term and can find the value of a and b. So this is our original method, but there are some different method also to find the value of a and b very quickly. I show you the new method, how you can make the solutions or you can find the values of a and b very quickly. You make one term, either this term or this term as 0 by putting some value of x. Suppose I want to make this term as 0, means simply you have to put 2 as x as 2 and this will make 0. So putting x equal to 2, that means this term is 0 and this term is 0. So what about the remaining terms? So remaining term 2 into 2, that is 4, 4 plus 1, that is 5, 5 will be here, is equals to this term is 0. So you have b times of 2 plus 1, that is 3, 3b, that means you will have 3b here, and that will give us b equal to 5 by 3. Very easily you can calculate by simply making the term 0. Okay, of course you can find the value of a and b by comparing, but that is a little lengthy process. Okay, dear students. So likewise, again, suppose I make this term as 0 now. So what should I put here? I must put x equal to minus 1, and that x equal to minus 1, that terms become 0 now. So remaining terms, so here when we are putting x equals to minus 1, so you will have 2 into minus 1 here, plus 1 will be here, and that is equals to a times of minus 1 and minus 2, that is minus 3, and this term is 0. So you will have your value of a here, that is minus 2 plus 1, that is minus 1, and this is your minus 3 times of a, and this minus minus cancel. So, your a will be 1 by 3. Very easily we calculate the value of a and b. Now, I can replace this a and b here and make this integrand as that is 2x plus 1 by x plus 1 x minus 2 as equals to a is what? A is your 1 by 3. So, 1 by 3 by x plus 1 plus b is what? B is 5 by 3, okay, 5 by 3 by that is x minus 2. That means I made this part as 1 by 3 by x plus 1 plus 5 by 3 by x minus 2. Now our integration become very simple. Now therefore your I is what? Integration, this part I have changed as this one. So I can write 1 by 3 by x plus 1 plus 5 by 3 by x minus 2 and dx is here. So I made two separate terms by taking this constant a and b. Now I make two separate integration. That means I take this 1 by 3 out, 1 by 3 taken out, integration dx upon that is x plus 1 and here is plus, so I put plus, and 5 by 3 again I take out, and integration of dx upon x minus 2. Okay, two separate integration I formed. I make the integration now over this. So this is 1 upon x plus 1. So 1 upon x plus 1, the integration of 1 upon x plus 1 is what? Log of mod x plus 1. That is equal to 1 by 3 log mod x plus 1 plus 5 by 3 log mod x minus 2, and that is C. So this is our answer. I made this integration which are given in the quadratic form, in the factorable form, and I made two separate terms over here, and then I done the integration. Very simple integration over. The main thing in this partial fraction is to make the parts. We make the parts separate terms. Okay. Now look at this problem. First, you have to check whether it is proper or it is improper. In the numerator we have x square. In the denominator we have again x square, that is quadratic by quadratic. That means it is improper. So you have to make it proper first. Then after you can find the integration of this one. So how to make a proper fraction? So that means you have to first divide it. That is x square minus 4x plus 3, we must divide this x square by this one. So what we have? You have 1 here and you have x square minus 4x plus 3. I change the sign. Okay. This part will cancel out. That will be plus 4x and minus 3. So our division is over because it is the linear form already we have. Here is quadratic, here is linear. So our division is over. Now this part I can arrange or I can write as integration, that is 1 plus that is 4x minus 3 by x square minus 4x plus 3, that is dx. So by dividing or by making it a proper one, I already get two terms. Now here the integration only we have one. The one is integration is very simple x. So this part is integrable. Now we go to this part only. So I have to make here, that is dx plus integration of 4x minus 3 by x square minus 4x plus 3 dx. It is exactly similar linear by quadratic one, but it is not given in factorable form. So I have to check I can make any factor over here or not. So let's check. that is equal to, here I can put simply x, integration is over here, and here integration, that is 4x minus 3 by, that is x square. Okay, I can write this 4x, 3x minus x plus 3 and dx. So this is equals to x plus integration of 4x minus 3 by, that is x and x minus 3, and here is minus 1, so x minus 3 dx. That means here I can write this is equals to x plus integration of 4x minus 3 by x minus 3 into x minus 1, and dx is here. Now see, this part is exactly similar to the previous question. So I leave this part for you, do in your homework, that is 4x minus 3 by x minus 3 into x minus 1 dx. Suppose you are given the question in this form, that means you have cubic expression in the denominator and that is factorable. We have three distinct factors. So how can we make it integration over here, that is 2x minus 1 by x minus 1, x plus 2, x minus 3, let would be, that is a by x minus 1 plus b by x plus 2 and c by, that is x minus 3. Now this one will be taken as 2x minus 1 by x minus 1, x plus 2 and x plus 3 is equals to a, and this is x plus 2 into x minus 3 plus b, that is x minus 1, x minus 3, and c, and your c will be what, that is x minus 1 and x plus 2 upon, that is x minus 1, x plus 2 and x minus 3. Now see, these terms and this part can be cancelled out. That means 2x minus 1 can be written as, 2x minus 1 can be written as a times of x plus 2, x minus 3 plus b times of x minus 1, x minus 3 plus c times of x minus 1 and x plus 2. So our target is to find the value of a, b and c. Same procedure I have to follow the rule by making the term 0. Suppose I want to make this term 0 now first. So what to do? You put value of x as 3. So when we put the value of x as 3, see what happened, putting x equal to 3. So that means you will have 2 3s are 6 minus 1, you have 5 in the left side, and in the right side this term becomes 0. This term x minus 3 is also here, we are putting x equal to 3, that means this term becomes 0, and here this is 3 minus 1, that is 3 minus 1, that is 2, and here 3 plus 2, that is 5. So 3 plus 5, 5, so 5 2s are 10, so 10c, you must have here 10c, that means your value of c is 1 by 2. Again I am putting x equal to what? Now I make this term as 0, that I put x equal to 1, x equal to, whenever I put x equal to 1, this term becomes 0 and this term also becomes 0. So here we are putting x equal to 1, so that means 2x in minus 1, so you will have 1 in the left hand side, and the right hand side 2 plus 1, that is 3, and minus 2, 3 minus 2, that is 3, and minus 2, that is minus 6. So that means minus 6 of a, and that means your a is what? Minus 1 by 6. Very simply you can calculate. And finally I want to get the value of b. So what do I want to make this term and this term as 0. So that means you have to put x equal to minus 2. When you put x equal to minus 2, so this term becomes 0. This term x plus 2 is here, so this term also becomes 0 now. Now from here, from the left side I am putting minus 2 to minus 4 and minus 1, that is give you minus 5 in the left hand side. and in the right hand side, I am putting minus 2 here, that is minus 3 and minus 5. Minus 3 and minus 5, that means minus 3 and minus 5 will be here. That means you will get 15 times of B, and when you bring this 15 in the left hand side, so B will be minus 1 by 3. So I get very easily the value of A, B and C. Now I can put this value of A, B and C over this one, and then I substitute this one in the integrand and do the simple integration. A means what? A means your minus 1 by 6. So minus 1 by 6 will be here, and your B is 1 by 3. 1 by 3 will be here, and your C is what? Your C is 1 by 2 will be here. That now look here, that is x minus 1, that is log of mod x minus 1, that is log of mod x plus 2 and log of mod x minus 3. This way you can solve the problems. Dear students, I think you have enjoyed today's lesson. In the next class we continue with some questions of this partial fraction of some different types. Some substitutions may be done. Okay, then we can go to the next section. Okay, thank you.